Hello guys, so this is lecture number 9 on JEE concepts, and again we are discuss questions on Newton's laws, and this is the second video in this regard, like on questions on Newton's laws. And in this video we are mainly focusing on pseudo force problem, like the problem in which inertial and non-inertial frames of references are involved. In the previous video we did some of the basic questions related to tension in strings, and one additional question on buoyancy force and force of resistance due to air. In this video, the questions are mainly on frames of reference. So let us begin. So the first question is, like a block A, this block can slide on a frictionless incline of angle theta and length L. This is angle theta basically, and this length is L. Kept inside an elevator going up with uniform velocity, this V. The question is asking that find the time taken by the block to slide down the length of the incline if it is released from the top of the incline. Released. Again, U is 0. That is initial velocity is 0 of this block. And it is released from this point. And it has to go till this point. So the question is asking to find the time in which this B is traveling from say this point P to say this point C. That is PC, and this lift is basically going up with uniform velocity. So remember what I taught, uniform velocity, this lift is going up. So this is what? Inertial frame, because it is not accelerating, and this uniform velocity is basically with respect to earth or with respect to ground, which itself is an inertial frame. So this is also inertial frame because it is going up with uniform velocity with respect to an inertial frame. And the similar question is given in the example of H.C.Verma. This is also a problem from H.C.Verma book, but this is from the problem section. In the example section, H.C.Verma has taken this velocity as acceleration A. So I'm also going to discuss this question here. Like what if this lift is basically accelerating upward with an acceleration A? Just this and the same question, like the time taken by this block A to reach from point P to point C while it is accelerating upward. So let us first solve this with uniform velocity. That is this question. So first of all, you need to have the system. So our system in this case is this block A. After that, you need to locate the forces. So the forces are like this mg downwards, and this normal reaction perpendicular to the surface. That is here N. Apart from this, there are not going to be any forces in this question because this is uniform velocity. So we are not going to have pseudo force because this is an inertial frame. Okay. So now the component of this mg in this direction will be what? Mg sine of theta, because this angle is theta. This angle is what? Theta. So if you divide this mg into the components parallel and perpendicular to the surface in which it is traveling, then this will be what? Mg cos theta. And in this direction, that is mg sine theta. So the normal reaction will be what? Mg cos theta only, because there are no other forces in that direction. And in this direction, like parallel to the surface, there is only one force, mg sine theta, because friction is 0. It is already given, frictionless incline. So there is only one force, mg sine theta. So that force is basically responsible for the acceleration of this particle of mass small m. We are taking the mass as small m. So that force is equal to mass into acceleration. So this mass cancelled out. Acceleration is what? G of sine theta parallel to the inclined surface. So this is the acceleration. Initial velocity is 0, and the length by which this mass needs to travel is this L upon cos theta. This is general trigonometry. L upon cos theta. Why? Because this is hypotenuse, this is base, and this is height. So cos theta is equal to base upon hypotenuse. We need to find the hypotenuse. So hypotenuse is equals to base upon cos theta. So that is the x. Now we need to find the time. For time, let us take this x is equal to ut plus of half at square. That is Newton's second equation actually. Second equation of motion. So this x is what? L cos theta is equal to u is nothing but this is 0. That is equal to half a is what? G sine theta multiplied by t square. Okay, so t square is equal to what? 2l upon g cos theta sine theta, and this half, that is equal to what? T, because I am taking this square as square root over here. So the answer to this question is very simple. Time is 2l upon g cos theta sine theta to the power half, whole to the power half. That is the answer. That is the time taken by the block to slide down from point P to point C. Now if the same question is not about this V, suppose this is about A, like this lift is accelerating upward. Again, this is theta and this is what? And this is what? L, this length. And if it is accelerating upward, like this lift is accelerating upward with an acceleration A, then this will become what? Non-inertial frame. Why? because now this reference frame is having acceleration, and accelerating frames of reference are non-inertial frame with respect to ground, obviously, because we are taking this acceleration with respect to ground, which is an inertial frame, and our observer is inside this lift. So this is a non-inertial frame, and here in this case we need to put a pseudo force because this is a non-inertial frame to make it compatible with Newton's second law. So since it is accelerating upward, so I have to give a force, this say ma in this direction, mass of this particle and acceleration of the lift, and the other force is what, mg, that is obvious in this direction, and this is again normal force. So let me divide these into the components, then it will be here what, we can directly write ma plus mg sine theta in this direction, and in this direction ma plus mg cos theta. So we don't have to do anything with this normal because there is no friction involved. So let us directly write the acceleration of this block of mass m parallel to the incline. So that will be what, force, that is ma plus of mg sine theta is equal to mass into acceleration, say a naught, because I have already taken a to this. So this m cancelled out, and we are having a naught is equal to a plus of g sine of theta. That is the acceleration of this block. Again this is released, so initial velocity is 0, and again the distance will be same, like x is equal to L upon cos theta. So applying again second equation of motion, x is equal to what, ut, u is 0, half a, like a plus g sine theta t square. So from here we can have this t is equal to what, 2L upon a plus of g cos theta sine theta whole to the power half, and this is nothing but our answer to this question when the lift is accelerating upward. And when the lift was having a uniform velocity in the vertical direction, then our time was 2L upon g cos theta sine theta to the power half, this one. So compare the time, this is t1 and this is t2. What do you think, which time is greater? Well, this a is basically positive in the upward direction because the lift is actually going upward, so this denominator is more, so this numerator will be, like t1 will be less, but this t2 will be more. So when the lift is accelerating upward, then it will take lesser time for this mass m to go from this point P to this point C. But when this lift is moving with uniform velocity in the upward direction, then the time taken by that block of mass m in order to reach from point P to point C will be more. So T2 is greater than T1. This is the inference. So in case of uniform velocity, it will take more time. The mass m will take more time from going to point P to point C. But when it is accelerating upward, then it will take lesser time for this mass m to reach from point P to point C. So this is the inference from this question. It is a good question actually. Now let us move towards the next question. This is the next question. A car is speeding up on a horizontal road with an acceleration a. Speeding up on a horizontal road. Okay, the road is horizontal. Suppose this is horizontal and this is the car. It is going with acceleration a, and that's why it is speeding up. Acceleration means what? The velocity is increasing with respect to time. Consider the following situations in the car. A ball is suspended from the ceiling through a string and is maintaining a constant angle with the vertical. So I have to make a different diagram for this car, not like this but somewhat bigger. Suppose this is our car. I'm not basically drawing the wheels, and this is a string. A ball is suspended from this string. When this car is moving in this direction, then obviously there will be a force in the backward direction, the pseudo force. So this string will move something like this. This trajectory will be something like this. Now this car is basically a non-inertial frame in this case. Why? Because it is accelerating, simple. And since it is a non-inertial frame, so we need to have a pseudo force in the opposite direction to the acceleration of this car, like this, m into a. Suppose the mass of this ball is m, then m into a in the opposite direction, and it is maintaining a constant angle with the vertical. Say this angle is theta. Find this angle. We need to find this angle. Okay, so let me have the system. So our system in this case is this ball of mass m, and when that is vertical, then it will be like this, and when this is at some angle, then it will be like this, and this is angle theta, like this. So the force is here in this direction, ma, this is horizontal, and in downward direction this is mg, and this is theta, and this is the string. So here will be tension. These three forces are basically acting on this ball. So now again we have to divide these forces into the components, one parallel to this string and one perpendicular to this string in this direction. So MA, this is basically theta, this is 90, this is 90 minus of theta, this is theta, again this is 90 minus of theta, and this will be theta. So here in this direction it will be mg cos of theta, and in this direction it will be mg sine of theta. Okay, for MA this is theta, this will be 90 minus of theta, so this will be theta, because this and this are again perpendicular. So this will be what? MA cos of theta, and this will be in this direction plus of MA sine of theta. So now we are having the forces in both the directions. So perpendicular to the string, the force balance will be something like this: MA cos theta will be equal to mg sine of theta. We need to find this theta. So this equation is sufficient, I think, because every other things are known, like this A is known, this G is known, and this mass is already cancelled out. So from here we need to find basically the angle, find this angle. So if I take this cos theta to this side, then A upon G will be what? Sin theta upon cos theta, that is tan theta. So theta will be equal to tan inverse A upon G. That is the theta basically, because A is known and small g is already known. So this is the angle that is made by this string with a vertical when this car is moving with an acceleration A in the forward direction. So this is the answer to the question number 1. Now let us read the question number 2. A block is kept on a smooth incline and does not slip on the incline. Incline. Suppose this is an incline. A block is kept on a smooth incline like this, say of mass m, and does not slip on the incline. Find the angle of the incline with the horizontal. It is not slipping. It is just at a point here. It means it is at rest, and this incline is having an angle theta with the horizontal. So we need to find this angle, basically this theta angle, and this is also inside the car. So the car is having acceleration in this direction only. So we again need to have pseudo force in this direction, m into A, and mg force in this direction, m into G. Okay, so we have to have the components in both the direction, in this direction and in perpendicular to the inclined direction. So this first situation, like when the string was having some angle with the vertical while the car is moving, in this situation our theta angle was what? Tan inverse of A upon G. Yeah, that was the first situation. This situation, let us divide the components. This is theta, this is 90, this is 90 minus of theta. So this will be theta because that is again 90. So if this is theta, then this will be what? MA cos of theta, and this is what? MA sine of theta. And here this is mg, so in this direction mg sine of theta, and here in this direction mg cos of theta. So again, if I equate the forces in this direction like perpendicular to the incline, then ma sine of theta is equal to mg cos of theta. So this m cancelled out and we are left with tan theta is equal to g upon a. Okay, so this is what I'm getting over here. Tan theta is equals to g upon a, and here tan theta is equals to a upon g. See over here, what a good mistake I have committed in this question. You need to note this mistake very clearly, because this is the kind of mistake that you are also going to commit. So it is good that I did this mistake in this question, in this very video. See what I did. I have taken this inclined plane like this and acceleration a in this direction. Okay, and I have located the forces by considering this mass m as the system. Now when I have taken the inclined plane just like over here, then the force in this direction is ma and in the downward direction is mg. So when you have the component like parallel to the incline, then ma will going to have a component in this direction and mg is also going to have a component in this direction. Both the directions of these components like ma cos theta and mg sin theta are same, while perpendicular to the inclined plane these are having different directions, so the forces are getting balanced perpendicular to the incline. But parallel to the incline, these two forces are in the same direction. But the question is, like a block is kept on a smooth incline and does not slip on the incline. So here, because of the net force in this direction, obviously this mass m is going to slip. But the question is, this mass m must not slip on the incline. And for that to happen, we must have these two forces in the opposite direction. Then only both forces get balanced, and then this small mass m is not going to slip on the incline. So that is the mistake that I committed, that both the forces in this case I have taken in the same direction, and that's why there is a net force in this direction, and because of which this mass m is definitely going to slip. So again I have to consider this incline in such a way that these two forces must be opposite to each other, and for that I need to have a situation something like this. This is the incline and this is the mass m, and now this is moving like the car is moving with an acceleration a in this direction, and in this case the ma force will be in this direction and mg force will be in this direction, and this is angle theta. So now when you consider the components, then for that let me have, this will be 90 and this will be 90 minus of theta, and this will be theta, this will be 90 minus of theta, and this will be theta. So ma here in this direction it will be ma sine of theta, and in this direction we are having ma cos of theta, and in this direction we are having mg sine of theta, and in the downward direction, not in the downward direction but perpendicular to the incline, we are having mg cos of theta, like this, and the normal will be here. So this normal force will be equal to ma sine theta plus of mg cos theta, but parallel to the incline, now this ma cos theta force and mg sine theta force are balancing each other, and that's why this mass m is not slipping on the incline. But in this case that I have considered at first, there is a net force parallel to the incline, and that's why this mass m is not going to stay but slip on the incline. So this is what I committed mistake. You have to keep your mind open while attempting questions like this, because in the first attempt just I have taken over here the situation in which both the forces are coming in the same direction, and this is the mistake that I did. So it is better that I committed this mistake in this video for you guys to not commit the same mistake in the future. So this is actually the case. So now just have the force like ma cos theta and mg sine theta to balance each other. Now here this m got cancelled out, and we are left with a upon g is equal to sine theta upon cos theta, that is tan theta. So again in this case theta is equal to tan inverse a by g. So in both the case, like in the first question this, and in the second case this, we are having the same theta, that is tan inverse a upon g, because both the cases are basically similar. One with a ball suspended to the string, and the another one a block on a smooth inclined plane. So both are basically the similar question. So just only by doing the question number first, I can say by confidence that in the second case also tan theta is equals to a upon g, because both are the similar question. So now let us move towards the third question, and the question is, a block is kept on the floor of an elevator at rest. The elevator is at rest. Suppose like this is the elevator and a block is kept over here of mass m say, and this is the elevator at rest, that is velocity is 0 of this elevator. The elevator starts descending. Descending means going down with an acceleration of 12 meters per second square. Find the displacement of the block during the first 0.2 second after the start, and g is given to be 10 meters per second square. Okay, so let us see what the question is basically asking, and let us attempt it. This is mass m. Initially the lift was at rest, elevator was at rest, v is 0, and suddenly it started to descend with an acceleration of 12 meters per second square. So again this is a non-inertial frame because it is accelerating, and because of this we have to add a pseudo force in the opposite direction like this, m into acceleration of 12, and the another force that will act on this mass will be mg, and g is what? 10. So m into 10 like this, and if there is to be normal, then the normal will be in this direction. So let me write the force balance. M multiplied by 12 plus of normal is equal to m multiplied by 10. So normal is 10m minus of 12m, that is minus 2m. Normal is negative. It means normal is acting in downward direction. What is the meaning of normal is acting in the downward direction? Well, this is the good question actually. The normal is acting in the downward direction. It means that this mass m has already left the surface and is in the air. Like this mass m already left the lift surface and in the air. Like now it is freely falling. It is not in contact with the lift, because this force, that is the upward force, is more than the weight of this mass m. That is this small mass m weight is m into g, and that is lesser than this m into 12 pseudo force. And so this mass is already left this lift surface, and that's why it is free falling. And because it is free falling, so we have to consider this mass, like observe this mass from the earth. like inertial frame of reference, because it is not in contact with the lift. So this mass m is not exactly within the scope of non-inertial reference frame. So we need to consider this with the Earth's reference frame because it is freely falling. And so the acceleration of this mass will be what? Minus of g, that is minus of 10 meters per second square. Why minus? Because in the downward direction. And initially it was at rest. So u is equal to basically 0. And time we already know, that is 0.2 seconds. So now again we need to apply the second equation of motion. So let me apply that. X is equal to ut, u is basically 0. So half at square, and that will be basically, x will also be negative because the acceleration is in the negative direction. So this x is what? Minus of x is equal to minus of half into 10 into t square is what? 0.2 square is 0.04. So then this is x, because this plus this is 5, and that is nothing but 0.2 meters. So the displacement of the block during the first 0.2 second after the start is 0.2 meters in the downward direction. It is actually freely falling because it has already left the lift surface, because the pseudo force is more than the weight of this mass. And that's why this is a very unique situation, because it has left the lift surface. And that's why the displacement of the block during the first 0.2 seconds will be considered just by taking the acceleration as minus of 10 meters per second square. Why minus? Because in the downward direction, because that is the weight, that is the acceleration due to gravity, because now this mass is only under the presence of gravity, not in the presence of this 12 meters per second square force, because this is now under the consideration of inertial frames of reference, not the non-inertial frames of reference, because it has already left the scope of non-inertial frames of reference, as it has left the surface of this lift, which was considered to be non-inertial reference frame. So this is a very good question. Just try to watch it once again. And this is all about this video, guys. In the next video also, we are going to discuss some of the fantastic questions, just like we did in this video and the previous video. So just watch these videos and try to learn as many question solving techniques as needed, or even more than needed, to excel in any of the competitive exams. So this is it, guys. Thank you.